Welcome back. In the previous video, we started solving this question and we considered the first part, which is the radius of the base circle of the cone. We are going to solve the remaining questions in this video, beginning with the height of the cone. In the previous video, we learned that, or we were able to find out that the base radius of the cone is 1.2 centimeters and the slant height of the cone is 7 centimeters. So if this is our cone with O as the vertex, B as the center of the base circle, and A as a point on the circumference of the circular base or the base circle, then the radius is 1.2 centimeters and the slant height, which is OA, is 7 centimeters. To find the height of the cone, we can see that if you pick the points O, B, A, we have a right angled triangle here, and the height of the cone will be given as OB. So we are going to apply the Pythagoras theorem on this right angled triangle to find OB. If you apply the Pythagoras theorem, you will have OA squared is equal to OB squared plus BA squared. Remember, we are looking for OB. We have OA as 7 centimeters and BA as 1.2 centimeters. So 7 centimeters squared is equal to OB squared plus 1.2 centimeters. If you simplify this, you will have OB as 6.9 centimeters. So the height of the cone is 6.9 centimeters. The question also said we should find the semi-vertical angle. So now we have the slant height of the cone, we have the base radius of the cone, and we have the height of the cone. In the first video on cones, we learned that the semi-vertical angle is half of the vertical angle. So if we let theta to be equal to the semi-vertical angle, then we can say that the angle that will be formed here is theta. Considering the points O, B, A, we have this right angle triangle with OA as 7 centimeters, OB as 6.9 centimeters, and BA as 1.2 centimeters, where theta is the semi-vertical angle. Okay, so the semi-vertical angle here is theta. We have 1.2 centimeters being opposite to theta and 7 centimeters as the hypotenuse. We also have 6.9 centimeters as the adjacent to theta. So here we can use any of the trig ratios and you'll be able to find theta. I'm going to pick sine. So sine theta will give us opposite, which is 1.2 centimeters, divided by the hypotenuse, which is 7 centimeters. So sine theta is equal to 1.2 divided by 7. Theta is equal to sine inverse of 1.2 divided by 7, and theta will give us 10 degrees. So we can say that the semi-vertical angle of the cone is 10 degrees. The question told us to find the vertical angle, not the semi-vertical angle. But in order to find the vertical angle, we first need to find the semi-vertical angle. We know that the vertical angle is equal to 2 times the semi-vertical angle. So if the semi-vertical angle is 10 degrees, then the vertical angle is 2 times 10 degrees, which is 20 degrees. So the vertical angle of the cone is 20 degrees. The question also said we should find the volume of the cone. The formula for finding the volume of a cone is 1 divided by 3 times pi r squared h. H is the height of the cone and r is the base radius of the cone. So the volume is equal to 1 divided by 3 times. The question said we should take pi as 22 divided by 7. So 1 divided by 3 times 22 divided by 7 times 1.2 centimeters squared times 6.9 centimeters, and you have 10.4 centimeters cube. So the volume of this cone is 10.4 centimeters cube. The question also said we should find the curved surface area of this cone. This is a hollow cone, so the curved surface area is the same as the total surface area, and the formula is pi RL, where R is the base radius and L is the slant height of the cone. The question said we should take pi as 22 divided by 7. So 22 divided by 7 times 1.2 centimeters times 7 centimeters, and the curved surface area is 26.4 centimeters squared. So the curved surface area of the cone is 26.4 centimeters squared. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on cones developed from the sector of a circle. Bye bye.